Right, so hi everybody. For those of you that don't know me, I'm Sue Daley. I'm Director of Technology and Innovation at techUK. And it's my absolute pleasure to be running and driving this techUK Talks session as part of London Tech Week, where we're in conversation today with Michael Cuthbert, the Director of the UK's National Quantum Computing Centre. Michael, really great to have you with us. Thank you so much for being with us today. How are you?
I'm very well, thanks, Sue, and thanks for inviting me. Delighted to be here.
So we were really keen and eager to have you as part of our techUK Talks, Michael, because as we've both been running around London Tech Week, as I know a lot of people have been, we were both at the Quantum Computing Summit yesterday, and I was there again today. And quantum seems to be really on the minds of people right now. And during the week, we've heard a lot about the quantum opportunities in the UK, where we are in quantum computing, where we're going. So we're really keen to have this opportunity, and thank you for taking the time to be with us and to just really, between us, have a bit of a conversation, explore your role, how the centre is developing, where you see the UK right now, where are we heading and how do we get there? So I think we're going to have a bit of a conversation between us. So I've got some questions I'd love to pose to you, if that's okay. But Then we've got many people on the call as well. So if you do have any questions or any questions come to mind while Michael and I are chatting away, please do pop them in the chat. And what we'll do is we'll try and come to them. But if not, I'm sure Michael, right, we can take them away and get back to folks. But if that's all right with you, we'll just kick off.
Super, yep.
All right, brilliant. So I know you and know all about your role, but there may be many people that don't. So Michael, could you just perhaps explain and talk through a little bit about because it's such an exciting job and role you have, and talk a little bit about some of the latest updates and news from the National Quantum Computing Centre, because I know you've had a busy week as well, right? It's been busy this week.
We have been busy, yeah. So, well, maybe if I just in a quick minute or so just say what the National Quantum Computing Centre is, because we're still quite new on the technology landscape. So the UK has had a National Quantum Technologies programme running since 2014. And that was initially focused very much on that translating academic research excellence through into business opportunity, commercial delivery, as well as plugging the skills gap across quantum technologies. And quantum computing is only one part of that. Sensing, timing, imaging, and secure communications are the other kind of key technologies. And as we've moved into the second a 5-year stage of the national programme, it was recognised that computing in particular has a very long roadmap, and there was a place on the landscape to establish a new national laboratory beyond the kind of academic hubs that had been really driving activity up until that stage. So we're establishing new national laboratory focused on quantum computing, the deployment of quantum computing and the development of quantum computing from the hardware through software and applications on the Harwell campus in Oxfordshire. And you're right, we have had a busy week, exciting week this week, because we broke ground on the new facility on Monday, which was fantastic. We had about 100 people at Harwell. And that was exciting because it was a really symbolic moment for us to move from the planning and really thinking about the design of the centre to that. Now we move on to construction and the operations of the centre. So that was, was a symbolic moment. I think it was also a fantastic moment because after the post-pandemic, it was really one of the first opportunities that right across the community, people have had a chance to come together and actually reconnect. So that's also important, just to have the opportunity to do that. For my role as director of the new laboratory, of course, there's the oversight of the whole program and project, but I see my key responsibilities really being to be able to provide vision and leadership for the program and where we fit in the landscape, you know, strategy and direction and how we actually deliver on that. I think connectivity and collaboration, and I'm sure we'll probably talk a bit more about that, but that connectivity across the National Quantum Technologies Programme. I sit on the programme board and strategic advisory board as well, and more broadly into the research ecosystem in the UK, of course, but I think also internationally. So we want to be able to connect internationally, liaising with government and across the rest of UKRI. So I think that's also about being a good citizen as we grow the new national laboratory, and then starting to develop the kind of long-term funding plans, understanding a sustainability of delivery and resources over time, and the kind of operating model of the centre might change over time. And I think the final point is, and that's probably number one on my mind right now, is building a team and then developing that team, and then with a longer term view on the sustainability, succession planning, and really development of that team. But the first point is so important to build the team. To build a facility with nobody in it would be a waste of time. We've got to build a great team to deliver on the program. Yeah,
it's exciting time then that we've caught you in terms of the beginning. Of course, you're not at the start, but with the breaking ground and really moving forward, it's great to have the opportunity to talk to you and see how that thinking is developing. Actually, I saw you talking at the Quantum Computing Summit yesterday. We were both there, which is really exciting. And I agree, I got a real buzz actually throughout all of London Tech Week, really. It's been the first time that I've seen many people in a long time physically and getting together. And I think I've really felt that buzz this week as well. You were talking, and many people were talking at the Quantum Computing Summit about the UK's quantum computing ambitions. We heard a lot yesterday around quantum readiness in the UK and how that's something we need to look towards. I wonder if you could share a little bit more about what that means to you and the kind of issues and areas you think the UK and we need to focus on to perhaps make that happen.
Sure. So I think in a nutshell, for me, quantum readiness is really about preparing certainly, from our perspective, the UK economy for the deployment and adoption of quantum computing technology over time. And so what does that mean? So I think quantum computing's got a really formidable ramp-up challenge. It's a highly technical subject area. And even if we had a quantum computer, and the technology roadmap is challenging enough, but even if we had a fully fault-tolerant quantum computer available tomorrow, there'd be a very limited community in the UK that could actually use it and do useful things with it. So we need to build that user community and have people thinking as the technology develops and scales about how some of the problems and use cases also develop and scale. And so what are the types of problems that we can address with fairly modest scale machines now? And how might that scale to some of the more challenging use cases that maybe the quantum computing offers potential for in the future? Along the way, I think we have to train people. We have to develop the skills, and I think we need to bring more people into quantum computing. So a lot is talked about in the kind of skills development, and that in a computing science, PhD physicists, and that of course is crucially important. But I think we already have a lot of highly skilled people in industry across many different sectors in the UK, and we need to create more awareness around quantum computing, its potential, bring people into the area, I'm involved with an initiative across the National Quantum Technologies program with the Institute of Engineer and Technology, to look at how we actually create awareness and develop skill sets and accreditation for engineers coming into quantum technologies, and not just physicists and computer scientists. So it's about skills, it's about awareness, it's about developing use cases. And then I think there's an educational piece for business leaders to understand where there could be structural improvements within their sector, where there's competitive advantage that could be achieved through quantum computing, where there might be threats and risks, data security, and so forth, where indeed they could be wasting their resources in exploring quantum computing rather than other technologies that might be more suitable for their sector. So there's a lot to be done, and I think at its heart is that kind of awareness and education.
Yeah, I think I agree with you on that, in terms of it's finding those stories as well, right? It's finding those case studies and examples that can help bring it to life as well. So it's not just seen as, I mean, it's a potentially transformative technology, right? Quantum computing. We had Richard Murray from Orca this morning on a panel describing it as the kind of potentially the moon landing moment of this era and this generation in terms of computing power and technologies and where that's going. So but it's how you translate that, right, into, in my mind, into, well, what does it mean in practice? What could it mean in reality? And finding the way to have that conversation. And I also wonder whether it's a technology that could also enable a conversation around other technologies, right? So it's not just quantum, but potentially quantum and AI, or quantum and edge, or quantum and supercomputing, and how these technologies work together, which I think has to be part of that conversation as well, if that makes sense to you.
I think you're right. And ultimately, end users will not care what compute resources they use to solve their problems. What they will care about is, do they solve their problems?
Yeah.
And how do they deliver benefits, whether that's to the bottom line and for their organizations, or improve customer delivery, whatever matters to them.
Yeah.
So some people, of course, will care the fact that it was a quantum processor that solved a particular problem, but it will just be part of a toolkit where AI and other classical high performance compute resources are also part of the of the mix. And there's some things that quantum computing may not be suitable for, that we will need these other technologies, I think particularly around AI and a machine learning from very large data sets, that will also be very important, that those technologies advance and grow as much as quantum computing.
Yeah, it does feel like a really exciting time to be having this conversation, though, because I think we are starting to move on, as you said, from not move on, because scientific research and discovery will always be hugely important here, right? But then it's how do we move on, not just the R, but to the D in R&D. How do we move on to the development, adoption, diffusion of these technologies, which will continue to evolve, right? We're only, of course, really at the start of this journey. And it's interesting you talk about business leaders, getting business leaders to understand the potential, right, of these technologies, and talking them through about that as well. Are there particular, in your work already, or be interested in your views, are there particular sectors or industries that you think that perhaps are ready for that conversation? We talk about readiness. Are they ready for that conversation, or are there industries and sectors where you and your work already are seeing potential that we need to therefore bring on this journey with us?
So I think there are industries, I think, that are particularly technology aware, who've been scouting for new technologies, and that's part of their the kind of delivery model. So certainly, I think the finance sector, the pharma sector, chemicals, advanced materials, and the automotive sectors have been particularly proactive. And certainly, I see that there's a really good starting point that's already developing, particularly around areas of kind of scientific computing and materials science, because I think in that space, there's solvable problems, because there's people already working on, on problems in chemistry, quantum chemistry and materials. There are very capable people with transferable skills, and they're already working in the problem space. And I think there is a challenge that we will need to tackle in this kind of education quantum readiness process, which is how do we get people to translate their problem space in structural biology, in aerodynamics, in finance, and how do we translate that into the language of the programmers and the quantum physicists to develop the algorithms? And we won't necessarily have people who are expert in everything. So I think there's a challenge there, but in quantum chemistry and material science in particular, I think we have people who have already bridged that gap very closely. So I think we can learn from there. There's clear research motivation, and I think there's a level of pent-up demand. I think people are already, really keen to explore how that might develop. And certainly across STFC and beyond into the academic community in the UK, we have a number of collaborative computing projects in these sort of domain areas that we're already thinking about how can we connect and roll out quantum computing resources to support that. We've been working with Bayes in actually trying to design our quantum readiness offering. So how do we actually run some of those programs from awareness and education through really exploring some use cases, applications, and then ultimately deploying quantum compute resources and advocacy for quantum computing as a technology that really makes a difference. So we've run a series of programs with the finance sector, and I said a little bit about this yesterday at the Quantum Summit in London, and that's been with the end users, so a lot of the financial services companies, the banks, with the regulators, so the Bank of England, and the accreditation authorities, with academics, and with the tech companies, to try and understand the problem space, learn from their experience of building teams, training people, and testing toy problems, and then also benchmarking and coming up with a return on investment or other measurables to say, how does this compare with other tools that might be out there for high performance compute capabilities? And so that's been at an early stage, but I think those have been very fruitful discussions and workshops to both help the NQCC come up with the model of delivery, but also really start to explore in the real life problem space how quantum computing can make an impact. The other sectors that I think, I'm very keen to explore, energy, right across the whole, in the widest sense, the energy sector. Pharma I mentioned, and chemicals, both very important to the UK economy. I think logistics is an area of interest. I know there's been quite a number of use cases and exploratory work done on logistics, particularly kind of picking and packing within warehouses, and the use of robots, so the robots don't crash into each other in large warehouses, those sort of things. I think there's more we can do in understanding logistics in the widest sense. And there's one thing about, picking and packing quickly, but then there's also the use of resources, fuel, time, manpower, in terms of how we then deploy goods around the UK from a logistics perspective. And then the one area that I feel that there's lots of scope to develop here, which is in scientific research itself. And I think particularly the role of quantum computing in machine learning, but right across scientific research, particle physics, CERN have a big program, chemistry and materials science I've already mentioned. I'm sure there are loads of other areas, but the delivery of science itself, I think, is a really interesting area where quantum computing can impact.
Yeah, fascinating areas to explore. And I'm sure if there are people on this call as well that have an idea as well of another area, please, do get in touch and do share, right? Because that's I think what we need to explore now is where could quantum computing and other, of course, quantum technologies really make a difference? What could it really help turn the dial on? And then that then leads to that, because we are, if we're talking about commercialization, if we're talking about moving to, the commercial deployment and potential of products and services, it's about getting people to use them as well, right?
That's right. And I think, Sue, you mentioned earlier the kind of telling a story.
Yeah.
I think that you're absolutely right. It's so important. And so if there are other use cases on a longer list that weren't on my short list, then the more we can tell the story and demonstrate impact, the better. And even if it's a particularly good use case in a sector that maybe there aren't other use cases, or it doesn't have huge economic impact, it is about demonstrating value and the power of quantum computing. So so I'm very keen to be able to tell those stories for sure.
Yeah, and so encourage people to got ideas, pop in the chat, or reach out to us or reach out to Michael directly, of course.
Yeah.
And if you've got any questions, do pop them in the chat as well. But I wanted to also ask you, Michael, because we had a session this morning, which was very much focused on that question of commercialization and where the UK is right now, where we're heading, what might be key to driving this forward or positioning the UK for success in this area. And I actually started off with a question to all the panel about what commercialization means to them. And I think you've kind of answered it, but I just wanted to just give you the opportunity, if you wanted to share it with us. We're going to hear a lot about commercialization of quantum. What does that term mean for you? And then you also touched on, your role of not just in the UK, but also looking internationally as well. Just be interested in your views of, what do you see, or where do you perhaps see the UK in terms of what other countries are doing around quantum computing and technologies, and what's your view from your perspective on that?
Sure. So on commercialization, to start with, I think for me, I've spent the last 20 plus years in industry, where we made products and had customers, and delivered services. So I think for me, commercialization has to be about real products and services that deliver market value, ultimately revenue, client satisfaction, and shareholder value. And that's what it's about. So I think that commercialization, that for me is what it's about. I think there's different mechanisms to get there. And certainly in the UK, I think we've been doing a good job with an eye on the translation of technology and commercialization as really the remit of the national program right from the beginning. Underpinning science is, of course, crucially important. And underpinning science is in what is now referred to as quantum technologies, but the underpinning science has really been something that the UK government has been supporting through academic research for the last 25 years. It may have had other names, whether it was nanotechnology or some of the semiconducting, superconducting devices in quantum optics. There's a whole range of things, but it's now been kind of classified under quantum technologies. I think from an international perspective, the landscape has become a little bit skewed by the huge investments that we see in the US and China in particular. The US, of course, has a number of very large household names, and the IT majors who, and particularly in computing, have been investing very heavily and have been making really significant progress. In China, I think the investment has been huge, really significant investment. A lot of that is, or the majority of that has gone into the kind of national laboratories and universities sector. So that's been much more on a research base. We're beginning to see some startup companies developing in China. There have been a small number of startups in the US and in North America generally. I think in Europe, there's been much more of a balance between the academic research and the commercial landscape, and the development and recognition of end users has been really important. And so perhaps greater level of engagement with those prospective industry partners as end users. I think in the UK, we've been doing well on this front. We've got, I think, 41 startups out of the national program, of which around half are in quantum computing. The UK also benefits from having a similar number and probably more of companies that are already quite mature, that are in the supply chain that deliver into quantum, whether that's in photonics, in cryogenics, in RF technologies. So there's a nice balance in the UK of both the supply chain, the startups, and the end users. And I think we've also been able to bring together those different groups, working with academics and national labs under some of the ISCF program, to bring consortia together to try and tackle some of these tough problems, technology problems, to accelerate the deployment of quantum technologies, and not just computing, but in some of the other areas as well. And some of the other areas are perhaps closer to market in terms of things like quantum sensing and secure communications. So I think there's an interesting mix in the UK that has put us in a really good place. Elsewhere around Europe, I'm beginning to see certainly a lot more startups developing. Startups being able to create investment to get them kind of up and running. And within that landscape, people recognizing that it's often good to partner and connect with others to be able to bring in resources and skills that they perhaps don't have within their own organization. And I'm beginning to see there's some clusters developing of people who are clearly enjoying working with each other and making the most of those kind of collaborative networks.
Yeah, so you actually read my mind, and we've had some questions pop in the chat as well, because I wanted to touch on this point about collaboration, partnership. So I think there is a role here, and to obviously, build that quantum ecosystem in the UK as well. And as you say, we're in a good place, and that is growing and evolving, I think, quite quickly. But it's also how we bring that new or that quantum ecosystem together with the existing tech ecosystem, and bringing the two together. We had one of the questions around, what's the synergies or the relationship or the opportunities when you bring quantum computing and AI together. So a great question in terms of, well, how do we bring those two communities together to explore those potentials? And we've had a few questions around, what's the centre's engagement plan and dialogue with other organisations, so public, civil society and organisations. So collaboration and partnership, to me, would seem to be a key part of your role or the centre's role going forward. And I wonder whether you might, is that right? Is we had a question around what's your deliverables, is engagement, is partnership a part there? And why do you think that's so important? Why is collaboration so important, playing a role across the programme and for the centre to going forward? Love to get your thoughts on that. And obviously there's a few other questions there if you see anything else that you just want to touch on as well.
Yeah, sure. So certainly I think collaboration is at the heart of both the successes that we've seen in the UK national programme, but in any strategy going forward. I think, particularly quantum computing, it's a pretty tough challenge. So I think the scaling of quantum compute resources is a difficult technological, theoretical, conceptual challenge. Never mind the engineering of actually making all of this work as it comes together. So no single organization or maybe even single country will actually get there on their own. So it is going to take collaboration and networking. I also think, we talked quite a lot about this yesterday, the challenge around skills and talent. I think it's inevitable that any individual organization won't have the brain power within their own organization to do it all either, even if they had the systems engineering skills. So I think the more we can collaborate, the more we cross-fertilize ideas, we learn from each other, and we can accelerate our activities just by tapping into great minds in other organizations. For the NQCC, I think our remit is about bringing people together, really convening resources, whether those are in industry and academia, and finding ways for people to work together. And if that means we bring people together and then we get out the way, that's great. I'm not so worried about us having to remain in collaborations. It's about having that connectivity across the landscape and bringing the right partners together and helping them work on some of these tough problems. And we've been, we've talked already about the quantum readiness program. We've already been doing a lot of work around engagement. I think particularly with the startup community and trying to connect into and understand what the startup community need in the UK and how we can help them. We also have a memorandum of understanding set up with the Quantum Computing Simulation Hub. And there are, of course, key threads that we have common goals there, I think particularly around skills and training, but other areas too. We've been connecting in across government, and there are quite a number of governmental departments with interest in quantum computing, from inward investment, job creation, to the technology deployment and the technology usage. And I think there's more work we can do there to understand how we connect more widely. And then the last point to mention across all of this is probably intellectual property. because it's always a challenge when it comes to putting collaborations together, consortia together, working openly with people about how do we manage IP. So we recognize the value of IP. We have no desire as a national lab to be hoarding or accumulating IP. We are very keen that the IP stays with the originator and that can be exploited. But that does mean there needs to be equity and fairness around what is well understood as the background IP, and how does foreground IP get developed and cross-licensed as appropriate. So I think that's potentially a barrier to collaboration, but one that we're trying to make sure that there's good rules of engagement from the outset, and that everybody understands the position that it makes collaboration easy and well understood, and not it doesn't get in the way of good collaborations going forward.
Really interesting. We had a question around how can, and I think just to we are running out of time, but just on how the centre can help support the industry in understanding where, when, where and how quantum computing can be used to support specific applications that industry need. Is that the work, would it be fair that's the work that you've been doing already with some of those industries and sectors to work through that? Or is that something the centre is going to be doing more of going forward?
So I think there's maybe two parts to that. There's engaging with the tech developers to see how can we help, whether that's in resources, in working with government to produce funding calls around specific topics, thinking about infrastructure, so things like nanofabrication. So do we have the right underpinning resources in the UK for the benefit of everybody? So there's certainly work like that we're very keen to support and help. We can't do it all ourselves and wouldn't seek to do it all ourselves, but we can certainly help with that. And then the other piece is about the engagement with the end users. And I think that's the Quantum Readiness Programme is really targeted at that, of being able to provide quantum compute resources, applications, support, and training so that industry sectors, whatever they are, can develop and engage with quantum computing. And then at some point, we will have done our job when actually they form commercial relationships, commercial partnerships with the quantum compute delivery, quantum compute as a service company offerings, and that we can stand back and say, okay, we've done our job there. We've got somebody up that learning curve, and we can move on to try and support others.
Yeah, you've enabled that organic relationship to occur, and it just happens, right? Yeah, absolutely.
Yeah.
So just coming to the end of time, really, and I was interested if we had a question around centres timeframes. So obviously you've had the groundbreaking this week, which is exciting, and I think you mentioned was slightly muddy, but who cares, right? It's still good to do. So what happens next in terms of timeframes and timescales, and what's on? Can you tell us a little bit about what we might see going forward?
Yeah, sure. So so the construction will start towards the end of the year, beginning of next year. The aim is that the facility will be complete in the spring of 2023. So we've, and then the fitting out of the laboratories, commissioning of equipment is going to take a bit of time after that. So we recognize that in the 5-year funding cycle that we have in our initial program to establish the NQCC, getting the building up and running actually is going to consume quite a bit of that initial period of time. So in parallel, we've been putting out technology commissions, and there's some that are already live at the moment. So we've already done some on software. and on applications and some on hardware, and we expect to expand that out and do more around some of those technology commissions. And that's a mechanism to try and put early revenue into the startups rather than grant funding. But it's also in an effort to accelerate the technology roadmap of both the startups and for the NQCC ourselves. So those are currently ongoing and will continue. Quantum readiness activity has now started, and that will continue, and that'll be a big focus, particularly in building a user community. That's a big focus over the next 12 months. And then I mentioned right at the beginning, the other piece that's very active at the moment is our hiring plan. So we've got about 65 people to hire between now and I would say the middle of 2023, so 2 years' time. And we have laid out, and anybody who's interested can have a look on the skills page on our website to just get a sense of timing. So we're not putting out all of the roles all at one time, all at the beginning. We've kind of phased it and see how the teams build up. So we're hiring, or we're close to the end of hiring the first 10 of our roles that were identified. The next 10 will be coming along over the next couple of months. And then we've laid out a plan. Every 6 months, we build up the team. So by the time that the centre, the main facility is up and running, we would anticipate about 65 staff right across the whole remit, from kind of business development through to the technology team and the facilities operational delivery of the centre.
Thank you for giving that outline. Really exciting to see that happening, and but also that the quantum readiness work is happening at the same time, right? Yeah. So it really sounds like a dual process, and I think it's a really exciting time to be talking about the future of quantum computing in the UK. And I know it's a busy time at the moment, so we really do appreciate you taking the time to be with us today, Michael. And unfortunately, we are running out of time. And I know we've got a number of questions, so what we'll do is we'll look to go through those questions as well, and share any that we can with folk afterwards. But Michael, just really thank you for taking the time to be with us today and to share with us your views and thoughts on the National Quantum Computing Centre, the UK quantum computing future, readiness, and where we are right now. I know everyone will have really appreciated hearing from you today, and just thank you so much for being with us and taking the time. And I hope, I wish you well for the future, and let's keep talking and seeing how the work here at techUK on quantum commercialization can support your efforts as well.
That's brilliant, Sue. Thanks very much for inviting me. And yeah, it was great, great session yesterday at the Quantum Summit. I really enjoyed participating and joining the sessions, and yeah, really glad to be able to join today and continue the conversation about all the activities that we're pursuing at the NQCC. So appreciate your support.
Not at all. I'm sure first of many conversations, Michael, but with that, I will say thank you so much and bring the session to a close. Remember, folks, we've got more techUK talks during London Tech Week. So the next one actually will be at 4 o'clock today on AI competitiveness in the UK. Very live, of course, Michael, with the National AI Strategy being launched yesterday by the UK government and the Office for Artificial Intelligence. So we'll have Sana Kurigani, the head of the Office for AI, with industry leaders from NVIDIA, Frontier Economics, and more later at 4 o'clock. Or please go back and watch the other techUK talks that have been happening throughout this week on issues such as the future of cloud, digital ethics, innovation, of course, around the innovation strategy from Bayes, and much, much more. So with that, I will say thank you to everybody. Michael, particularly, thank you for joining us today. We hope you found that conversation useful, and we look forward to seeing you all again very soon. Bye-bye, everybody. Bye-bye.